Good morning! It's me, Juliet Barnachea, and welcome to our class. Our topic for today is about calculating mean and variance of a discrete random variable. For today's objectives, we will apply the important concepts of mean and variance of a discrete random variable. Calculate the mean and variance of a discrete random variable. If you took an examination, do you sometimes think of where would be your score lie? Would it be below or above the average score? Afterwards, you would like also to know how far you are from the average score. Finally, you would ask yourself what is the meaning of those locations from the center or mean of the probability distributions. If you are asking these questions, this lesson is designed for you. In this lesson, we can calculate and solve the average of a discrete random variable. The term average is the mean or the expected value or the expectation in probability and statistics. Once we have calculated the probability distribution for a random variable, we can calculate its expected value. The mean of a random variable shows the location or the central tendency of the random variable. Let us start with a review. The number of COVID-19 patients seen in the ER and in any given hour is a random variable represented by X. The probability distribution for X is presented below. And let us answer the following questions. Find the probability that in a given hour, letter A, exactly 17 patients arrive, letter B, at least 16 patients arrive, and letter C, at most 18 patients arrive. Number 2, what is the average number of COVID-19 patients who arrive in the ER in an hour? Number 3, illustrate the mean and standard deviation of the data gathered. To answer the following question, let us start with number 1. Find the probability that in a given hour, letter A, exactly 17 patients arrive. So looking at the given table, 17 patients has the probability of 0.2. So it is the answer 0.2. Letter B, find the probability that in a given hour, at least 16 patients. So at least, meaning 16 is the least number of patients. So including 16 up to 19. So get the probability of 16.2 plus the probability of 17, that is also 0.2, the probability of 18, that is 0.1, and probability of 19, that is also 0.1. Adding all these four, we have 0.6 as the probability of at least 16 patients arrive. Letter C is to find the probability that in a given hour, there is at most 18 patients arrive. At most, meaning the most number of patients. This is the largest number. So, that means from 18 down to 15. So, get the probability of 15.4 plus probability of 16.2 plus the probability of 17, also 0.2, and probability of 18, that is 0.1. Adding all these four, we have the probability that at most 18 patients arrive is 0.9. For number 2, what is the average number of COVID-19 patients who arrive in the ER in an hour? Looking at the given table, 17 is at the middlemost, Therefore, our mean is 17. Number 3 is to illustrate the mean and standard deviation of the data gathered. We can have the illustration by showing this one. First, as you can see, our mean is 17. So we have this one as 17 at the middlemost. And then getting you elements at the left side of 17 are 15 and 16. Adding these two will give us 31. And elements at the right sides of 17 are 18 and 19. Adding 18 and 19 will give us 37. 31 plus 17 divided by 2 will have 34. Or in short, 31 plus 34 plus 33 divided by 3 will give us 34. And then, getting the difference of 34 and 31 will give us 3. And 37 and 34 will give us also 3. As you can see, they are the same. It shows that the elements spread 3 away from the mean, which implies its variability. Let us read and analyze the given situation. Mr. O'Malley, a mathematics teacher, regularly gives a formative assessment composed of 5 multiple-choice items. After the assessment, he used to check the probability distribution of the correct responses, and the data is presented. Based on the data, observe and analyze and answer the following questions. Number 1. What is the summation of the probabilities of the given random variable? When we say summation, meaning we will just add all the value of the probabilities. And the answer is 1. Number 2. Why is it that the probability of a random variable x is less than 1 but not negative value? The probability of the discrete random variable x lies between 0 and 1. So it is impossible to have a negative probability. Number 3. What is the average or mean of the given probability distribution? The answer is 3.41. And for number 4, what are the values of the variance and the standard deviation of the probability distribution? The answer is variance is equal to 1.5819. If you are wondering how we came up with the answer for questions 3 and 4, you will understand everything as we go on our discussion. In the previous module, mean or expected value characteristics had been presented, even variance and standard deviation of a discrete random variable. Expected value or mean value is the sum of the products of each possible value of a random variable and that's value's probability. In symbol, we have expected mean is equal to x sub 1 times probability of x sub 1 plus x sub 2 times probability of x sub 2 plus up to x sub n times probability of x sub n. Or in short, the formula for mean is equal to the summation of x times the probability of x. Using the given data in our first example, let us find the mean. For us to find the mean, we will have to follow the given formula. X is equal to the summation of X times probability of X. So therefore, giving the value of X as 0, 1, 2, 3, 4, and 5 coming from this data, and copying the probability of X coming also from this data, all we need to do is just to multiply the X and the probability of X. So we have 0 times 0.03 is 0. 1 times 0.05 is 0.05. 2 times 0.12 is 0.24. 3 times 0.30 is 0.9. 4 times 0.28 is 1.12. And 5 times 0.22 is 1.1. For us to get the mean, since the mean is just the summation of X times the probability of X, in short, we will just have to add all of these. Adding 0 plus 0.05 plus 0.24 plus 0.9 plus 1.12 plus 1.1 will give us 3.41 as the mean. The formula in finding the variance of a discrete random variable x is this one. Variance is equal to the summation of x minus mean squared times probability of x. Remember that if the value of the variance is small, then the values of the random variable are close to the mean. The standard deviation of x, denoted by delta sub x, is the square root of the variance. In symbol, the formula for standard deviation is equal to the square root of the variance. Moving on, for us to find the variance, we will still be using the same given. Since we are through finding the mean and we come up with the mean equals 3.41, coming from the summation of x times the probability of x, we will continue this by simply adding x minus mean. Take note of the formula of the variance that is equal to the summation of x minus mean squared times probability of x. So after getting the mean, next step is to get the difference of the outcome or the x and the mean. To start with, we will have 0 minus the mean minus 3.41 is negative 3.41. 1 minus 3.41 is negative 2.41. 2 minus 3.41 is negative 1.41. 3 minus 3.41 is negative 0.41. 4 minus 3.41 is 0.59. And 5 minus 3.41 is 1.59. Remember, you are allowed to use a calculator. Next step is to square the difference that we have from x minus mean. Squaring means multiplying it by itself. So for us to get the square of x minus mean, we have negative 3.41 times negative 3.41. The answer is positive 11.6281. It is now positive because any negative number multiplied by a negative number, the result is always positive. Negative 2.41 times negative 2.41 is 5.8081. Negative 1.41 times negative 1.41 is equal to 1.9881. Negative 0.41 times negative 0.41 is equal to 0.1681, and 0.59 times 0.59 is 0.3481. 1.59 times 1.59 is 2.5281. Our next step is to multiply x minus mean squared times the probability of x. So this one and this one. 11.6281 times 0.03 is 0.3488. 5.8081 times 0.05 is 0.2904. 1.9881 times 0.12 is 0.2386. 0.1681 times 0.3 is equal to 0.0504. And 0.3481 times 0.28 is 0.0975. 2.5281 is times 0.22 is equal to 0.5562. And the last step, since the formula for variance is the summation of x minus mean squared times probability of x, all we need to do is to add all of this. Adding all this together will give us 1.5819. The variance is 1.5819. And the standard deviation is the square root of 1.5819 and it is equivalent to 1.26. Therefore, the correct answers for question 4 are 1.5819 and 1.26 respectively. Take note on units. Standard deviation has the same units as x. Variance has the same units as the square of x. So, if x is in meters, then the variance is in meters squared. Since standard deviation and x have the same units, the standard deviation is a natural measure of spread. In some ways, the standard deviation is the more tangible of the two measures, since it is in the same units as x. Let's have the next example. Suppose that a coin is tossed twice so that the sample space is head-head, tail-head, head-tail, and tail-tail. Let x represent the number of heads that can come up. Based on the prepared discrete probability distributions on the random variable x, calculate the mean, variance, and standard deviation. So here is the probability distribution. Applying the concept from the activity given, let us complete the table. Applying the concepts from the activity given, let us complete the table. Our aim is to find the mean, the variance, and the standard deviation. Take note that the formula for mean is the summation of x times probability of x. So for us to get the mean, we need to construct a probability distribution wherein from the set data given a while ago for tossing a coin, we will list down all the possible outcomes and the value of the random variable. The random variable is the number of heads. The value of the random variables are 0, 1, and 2. The probability of getting 0 is 1 over 4 or 0.25. The probability of getting 1 is 1 half or 0.5. The probability of getting 2 is 1/4 or 0.25. After having these two, the value of x and the probability of x, we will multiply it. Multiplying it will give us 0 times 0.25 is 0. 1 times 0.5 is 0.5. 2 times 0.25 is 0.5. For us to get the mean, we will just add all of this, since the formula for the mean is the summation of x times the probability of x. Adding all these three will give us 1, and that is our mean. Our next step is to find the variance. The formula for variance is equal to the summation of the square of x minus mean times the probability of x. So from getting the mean, we will add another step. We will subtract the mean from the x. So x minus mean. So 0 minus 1 is negative 1. 1 minus 1 is 0. And 2 minus 1 is 1. After getting the value of x minus mean, we will multiply all of this by itself for us to get the value of x minus mean squared. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. After that, and for the last step, second to the last step, we will multiply the square of the difference of the x and the mean by the probability of x. So 1 multiplied by 0.25 is 0.25. 0 times 0.5 is 0. And 1 times 0.25 is 0.25. And for us to get the variance, since it is the summation of x minus mean squared times probability of x, we will just add all of this. So 0.25 plus 0 plus 0.25 will give us 0.50. And this is our variance. The variance is 0.50, the mean is 1. For us to get the standard deviation, since standard deviation is just the square root of the variance, therefore, we have 0.50. The square root of 0.50 is equivalent to 0.71. We have discovered that the expected value is only the average or mean of the random variable x. It's occasionally called a weighted average because more frequent values of x are weighted more highly in the average. It is additionally how we anticipate that x should behave on average as time goes on. The mean of a random variable x is a measurement of the central location of the distribution of x. If we are summarizing features of the distribution of x, it is clear that location is not the only relevant feature. The second most important component is the spread of the distribution. Again, the variance of a discrete random variable x is defined by the summation of x minus mean squared times probability of x, where the sum is taken over all values of x for which probability of x is greater than 0 but less than 1. So, the variance of x is weighted average of the square deviations from the mean, where the weights are given by the probability function of x. The standard deviation of x is defined to be the square root of the variance of x. That is, the standard deviation is equal to the square root of the variance. Because of this definition, the variance of x is often denoted by delta squared sub x. In other way around, the standard deviation is the more tangible of the two measures, since it is the same unit as x. For example, if x is a random variable measuring length in centimeter, then the standard deviation is in centimeter, while the variance is in centimeter squared. Remember that with respect on units, standard deviation has the same units as x. Variance has the same units as the square of x. So, if x is in meters, then variance is in meters squared, because standard deviation and x have the same units. The standard deviation is a natural measure of spread. Always remember that the variance cannot be negative, because it is an average of squared quantities. This is appropriate, as a negative spread for distribution does not make sense. Hence, the variance is greater than or equal to 0 and standard deviation is greater than or equal to 0. Let's have more examples. The number of shoes sold per day at a retail store is shown in the table below. Illustrate the mean, variance, and standard deviation of this distribution. Of course, we will tabulate the given data. We will put x here such that these are 19, 20, 21, 22, and 23. And then followed by probability of x. Probability of x of 19 is 0.4. Probability of 20 is 0.2. The probability of 21 is 0.2 and the probability of 22 is 0.1, as the same with 23.1. Next step is to find the product of x and probability of x so that we can have the value of the mean. We will multiply x and the probability of x. So, finding the product of 19 and 0.4, we'll have 19 times 0.4 is equal to 7.6. 20 times 0.2 is equal to 4. Reminders, you are allowed to use calculator. 21 times 0.2 is equal to 4.2. 22 times 0.1 is equal to 2.2. And 23 times 0.1 is equal to 2.3. Adding all of this will give us the mean. So we will add 7.6 plus 4 plus 4.2 plus 2.2 plus 2.3. And we have 20.3. And this is now the mean. We now have the answer for the first question. Mean is equal to 20.3. Next is to find the variance. Variance is equal to the summation of the square of x minus mean times probability of x. So we will have the next step to find the difference of x minus mean. So we will get the x minus 20.3 is negative. You can use calculator to lessen your error. minus 19 minus 20.3 is equal to negative 1.3. 20 minus 20.3 is equal to negative 0.3. 0.3. 21. 21 minus 20.3 is equal to positive 0.7. 22 minus 20.3 is equal to 1.7. And 23 minus 20.3 is 2.7. Next step is to square the x minus mean. In short, multiplying this by itself. So, negative 1.3 times negative 1.3 is equal to 1.69. Negative 0.3 times negative 0.3 is equal to 0.09. 0.7 times 0.7 is equal to 0.49. And 1.7 times 1.7 is equal to 2.89. Then, plus 2.7 times 2.7 is equal to 7.29. After this step, we will now multiply x minus mean squared by the probability of x, so that we can have all this part. So we have 1.69 times the probability, 1.69 times the probability of 0.4, answer is 0.676. 0.09 times 0.2, 0.2 is equal to 0.018. 0.49 times 0.2 is equal to 0.098. 2.89 times the probability is 0.1, that is 0.289. 7.29 times 0.1 is equal to 0.729. And for us to get the variance, all we need to do is to add all of this, because variance is the summation of x minus mean squared times probability of x. So adding all of it, 0.676 plus 0.18 plus 0.098 plus 0.289 plus 0.729. what we have is variance is equal to 1.81. And this is our variance. For us to get the standard deviation is just the square root of the variance. So in short, standard deviation is equal to the square root of 1.81. Plugging into the computer, square root of square root of square root of 1.81 is equal to 1.35. And here it is. So here is the mean. The variance is 1.81 and the standard deviation is equal to 1.35. For your task, I want you to do the following. It will be posted in the Google Classroom. Your answer is expected to be turned in also in the Google Classroom. That's all for today's discussion, and I am leaving you with a quotation. Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. And if you are new with my channel, I am Juliet B. Don't forget to subscribe and hit that bell button for you to be updated with our video lessons. Goodbye and see you next lesson.